Hello everyone. In this video, I am going to discuss about one of the most important aspects of system Verilog when you are dealing with nested classes. So, what happens in a nested class? Inside a nested class, you are just declaring a handle of another class. So, when you try to copy the class which has a handle of another class to another handle or another object, there are some issues, which brings up the topic of deep copy and shallow copy, which is the main focus of today's video. So let's begin with a very simple example in which we will be creating a class for data packets. So first I will begin with the low level class. I will call it statistics, and it will have only two properties of type int. So first one is start time and the second one is of stop time. So I will end the class. Now I will write the data packet class and I will name it transaction. So first I will write the properties of this class. So I will have a 32-bit address and CRC bits and data which is an packed array of 32-bit of 8 packed elements. So each of the 8 elements will be of 32 bits. Now I will declare the handle for the class which I want to nest inside this class transaction. I will name the handle stat. Now I will declare another variable id and I will also declare a counter. And I want it to be static, because using that we can generate new unique IDs, and I will mention the IDs inside the constructor function. So let's begin with the constructor function. So I want to assign the object to the handle stat, and the other thing I will do is to assign the variable ID with the incremented value of count, and I will use the post increment operator. So the very first created object will have the ID of 0 and the next one will have ID of 1, because it will first get assigned to ID, then it will get incremented. So first I will check for any. Okay, I did a typo right here. It is supposed to be and class. So let's begin with our top level module. I will name it test. So inside that, I will declare two handles for the class transaction, and I'm going to name the first one as src, which stands for source, and the second one will be dst, which stands for destination. Now I will begin with my initial block. So inside the initial block, first I will assign an object to the handle src. Now I will assign some value to each of the properties which are mentioned right here. So first I will assign some value to address. So before that, I just want to show you the difference between uh, the copying methods and the way of only using the equal operator. That is that both the handle will be pointing towards the same object. So what if I just make dst equals to src? So as I have already discussed in my earlier class, using that dst and src, both of them will point towards the same object. So if I make any changes to either of them, it will be reflected to each other. So I am assigning some value to the address of the handle src, and now I will assign some value to the crc bits. Let's assign 1 to every bits. Then for the data, I will iterate through each of the elements, and there are total number of 8 elements, and each element is of 32 bits. So it is pretty obvious that for the 0th element, 0 will be assigned, and for the first element, 1 will be assigned, and so on. So I will use our display system task to print out the value of the properties of dst. My second argument should be the crc bits, and my final argument should be the data. And for this, since it's an unpacked array of 32 bits element, I will just use the %p. So let's go ahead and compile the code and let's check whether I have done any typo. Okay, the code is fine. So I will just go ahead and simulate the code. So as you can see right here, the value that we assign to the object of src is also affecting the object of dst, and it is because of that we are using the regular blocking assignment between both the handles. So using that, it basically forces dst to point towards the same object towards which the src is pointing at. So this is not an example of copy. So I will move with the shallow copy, in which DST should have a separate copy of its own object. So to do that, you just have to add the new keyword before the object which you are copying. So using that, DST will have its own copy. So now let's simulate the code for one more time and let's find out whether the change in the object of src is affecting DST in any way. So if it does not affect, this display system task should print the default value of address, CRC, and data. So let's find out. So as you can see right here that this time the change in SRC is not affecting the properties of DST. So this is shallow copy. So in shallow copy, we copy every properties and methods, but the catch is that the only top level objects with their properties and methods are copied. So the lower level objects or the nested class are not copied. So let's find out what is happening to the handle which is mentioned right here. So I will try to make changes using the handle or handle src to the properties of stat, and we will observe whether it make any changes for the very same properties for the handle dst. So I will go ahead and assign some values to both start time and stop time using the handle of src. Let's give it 1 2 3. and let's give this 44. So I will write another display system task for DST to check whether its own copy of start t and stop t is getting affected or not. Okay, let's go ahead and compile the code. Okay, it does have some errors, so let's find out. Okay, so I have declared the handle right here as stat. I should have declared it as stats. I will change it to stats, and let's compile the code for one more time. Okay, it still have one error. Oh yeah, right here. I need to change it here also. Now it should compile just fine. Yep. So I will go ahead and simulate the code. So as you can observe right here that I assigned some values using the handle src, and I displayed the values of the DST handle or object, yet it does affect. So src does affect DST, which basically means that even though src and DST have their own copies of properties and methods, but, but for the nested class, they are pointing towards the same object. So both src and DST have one low-level class handle that is stats, and that stats is pointing for both of them towards the same object. So that is where the concept of deep copy comes into play. So in deep copy, both the object should have separate copies. So both handles should be pointing towards the separate copies for both the properties, methods, and even the nested class, the low level class, or the handles which are instantiated inside the class. So it's a bit lengthy process as compared to the shallow copy. So you just have to create another method in each of the class, whether it's the top level class or whether it's the nested class. So I will show you how to do that. So I will just begin with my nested class, which is statistics, and I will create another function, and the return type of that custom function should be the class itself. So for this case, it should be statistics, and I will name this function copy. So I am choosing the return type to be statistics because this function is meant to be designed to create an independent copy of an object. So let's break it down. So first, I will assign an object to the function. So this just create a new and separate copy or a separate object for the class statistics. So now what I will do, I will just copy all the properties to this object, which is just a copy of this class. So to do that, I will just write copy dot start t, and I will refer to the properties which is mentioned right here, which are mentioned right here. And the last one is the stop time. So using this, we are creating a function that will help in creating a separate copy of statistics with its properties and also functions or methods if you have any. So let's go ahead and work around with the class transaction. So as I have said earlier, that you need to implement this function for both the top level class and the low level class. So I will create another function, and like the previous function, the return type should be of the class itself. So here the class is transaction, and I will name this one also copy. So the very first thing I will do is that I will create a new object of the copy. So after assigning the object, I will begin with copying the properties like I did right here. So there are three properties. First is address. The second one is CRC. And the third one is data. So here we are just focusing on the methods which are mentioned right here. I can use the ID and count to copy, but it is of no use right now. So because at the end you want every object to have its own unique ID and the count is static, so it does not matter. So our main focus of properties are these. So the last one is, of course, data. So after doing this, we have a last thing to do, and that thing is to copy or create a separate copy of the nested class. And this can be done just by referring to the handle, which is stats, and assigning it to the method of the nested class. So that method is copy. So just by assigning this uh, to the copy method, it will just copy everything. It will call that copy function of the nested class and it will begin copying the properties of the nested class. So this will just kind of perform a deep copy in a recursive way. So it does not matter how many class you nest inside the top level class, you have to call your custom copy method which you have created inside the nested class. So I will go ahead and save the code. So now this is going to be very simple. So here we were doing the shallow copy. So I will just remove the new keyword and I will call the copy method of the object src. So first I will check whether I have made any mistakes. So I will go ahead and compile the code. Okay, the code is just fine. So now let's find out whether the handle src it's pointing towards the same object of stats as the dst or not. So I will go ahead and simulate the code. Okay, there is a runtime error. Okay, so okay, at line number 23, I just made a typo. Now it should work. So as you can see right here that we assigned some values using src to the properties of the nested class, and it does not affect to the properties of the nested class which is mentioned inside dst. As you can see right here that it is printing its default value here of 0 for both start time and stop time. So this concludes the definition of the deep copy. So there are basically three means of copying an object. The first one is just using the equal to operator or the blocking assignment between both the handles. In such case, you are not copying anything and you are just making two handles to points towards the same object. And the second option is to use the new keyword, in which you will be able to copy all the properties and methods of the top level class, but you cannot do the same thing for the nested class, which I have mentioned right here. So for the nested class, both the separate handles will be pointing towards the same object. So to counter that, we have implemented a separate custom function which will perform the deep copy. So in deep copy, it includes everything. It includes copy of everything, whether it's a property or method or even a nested class handle. So everything will be pointing towards the separate object. So that was the difference between deep copy and shallow copy when you are dealing with a nested object. So I hope you find this video useful and stay tuned for more. Thank you so much.